Morning, students. Light, Steph. Wisdom, Daniela. Chidera. Collins. Amanda, how are you guys doing? Hope your day is moving smooth. Alright. Get your writing materials. Today we're going to look at the topic in chemistry, which is Dalton's law of partial pressure. Dalton's law of partial pressure. The last time we met, we discussed ideal gas law and general gas law. Ideal and general. But today we are going to look at Dalton's law of partial pressure. And under this topic, we have two objectives. One is to be able to state Dalton's law of partial pressure and to solve problems on it. So get your calculator, the writing materials. Let's go. We are starting with this. The meaning of Dalton's law of partial pressure. If you're asked to state Dalton's law of partial pressure, Dalton states that in a mixture of gases which do not react chemically together, if you are mixing two or more gases, listen attentively. If you are mixing two or more gases and the gases do not react chemically, then for you to get the total pressure of the mixture of the gases is to sum the individual partial pressure. That is what Dalton said. To get the total pressure of two or more gases that do not react chemically, just sum their individual partial pressures. So let's look at what we have here. Dalton's law of partial pressure states that in a mixture of gases which do not react chemically together, the total pressure of the mixture of gases is equal to the sum of the partial pressure each gas would exert if it alone occupies the whole volume of the container at the same temperature. Make sure you are jotting something down. Make sure you are writing something. Make sure you are writing something. Okay? So what does this mean? If you have two gases and you happen to see that both gases are not reacting, for you to get their total pressure, just add their individual partial pressures. You are good to go. Very simple something. You see the diagram there. The first gas, which is P1, the pressure of the first gas plus, that is what we call the partial pressure. The partial pressure of the first gas plus that of the second gas will give you the P total. That is what we call the total pressure. So if you are looking for the total pressure, just add the individual partial pressures. Mathematically, what is he saying? That P total is equals to P for gas A plus P for gas B plus P for gas C. These P's are partial pressures. Partial pressures. So partial pressure, if you want to find or get partial pressure itself, it is the number of moles of that gas, of a particular gas you are looking for, over total number of moles in the mixture times the P total. You're jotting them down. For you to get partial pressure now, it is the number of moles of that gas you are asked to find over the total moles of the whole gases, that's the mixture, times P total. But if you are looking for P total, just add the individual pressures of the gases that are combining. But what if you are looking for number of moles, just use the formula, which is partial pressure is equal to number of moles of that particular gas over total number of moles of the mixture times P total. Do you get what I'm saying? I'll repeat it again. The formula for partial pressure, which is pressure of one gas. Partial pressure is the pressure of one of the gases that is reacting. The formula is number of moles of that gas we are asked to find over total number of moles of the mixture times P total. That P total is what? The total pressure. Now, if you are asked to find the total pressure now, you are not asked to find the partial pressure, but total pressure, what are you going to do? The formula is simple. Just add the partial pressures of the gases, which is PA plus PB plus PC, as the case may be. Okay? Do you understand what I'm saying now? Okay. Now let's look at the calculations. One says, a mixture of helium, neon and argon gases have a total pressure of 790 millimeter mercury. Listen and listen. We have a mixture of what? Helium, neon and argon. These three gases do not react, remember, because they are noble gases, they don't react. Do you remember? Noble gases, they don't react. So we have mixture of helium, neon and argon, and they have a total pressure of what? 790 millimeter mercury. So the P total here is 790. Now, if there is 15% argon, 60% helium and 25% neon, the question says, what is the partial pressure of each gas? What is the partial pressure of each gas? Now, remember, in this case, what is given is the percentage of each of the gases involved. How many gases do we have here? 3. Argon, neon and helium. Now, for you to get the partial pressure, just pick each percent, divide by 100, then times by the total pressure. That is what you're going to be doing to get their individual partial pressure. For argon, the percentage is 15. So if you want to get the partial pressure, it is 15 over 100 times the total pressure, which is 790. It will give you 118.5 millimeter mercury. Punch it. 15 over 100 times 790. For argon, the percentage is 15. So for you to find the partial pressure of argon, it is 15 over 100 times the total pressure, which is 790. Have you done that? 15 over 100, which is 15 over 100, 15 divided by 100 times 790. The answer will give you 118.5 millimeter mercury. Done? Okay, the second one, which is helium, the percentage is 60. So for you to get the partial pressure, it is 60 over 100 times the total pressure, which is 790. Punch it. 60 over 100 times 790. It will give you 474 millimeter mercury. Punch it. Then the last one, which is neon, the percentage is what? 25. So for you to get the partial pressure, it is 25 over 100 times 790. Punch it. 25 divided by 100 times 790. The answer will be 197.5 millimeter mercury. Now, if you want to know whether you are correct, after you must have gotten the individual partial pressures, add them, sum them up. It will still give you that total pressure, which is 790. If you didn't get it, then you are wrong. So sum the three of them. It must give you 790 millimeter mercury. Of course, you must put the unit. Very important. Are you with me? Let's look at the second one. The second one. The partial pressure of carbon dioxide in a mixture of gases is 0.8 atm. Another unit for pressure is what? Atm. The partial pressure of carbon dioxide is given, which is 0.8 atm. If the total pressure is 1.05 atm, what is the mole fraction of carbon dioxide in the mixture? In this case, you have the partial pressure, we have the total pressure, and we are looking for mole fraction. And we have the relationship between mole fraction, partial pressure, and total pressure, which is, do you know? Mole fraction is equals to the partial pressure over the total pressure. If you have the partial pressure divided by the total pressure, you have your mole fraction, as simple as ABC. As simple as what? ABC. There is nothing that is hard in chemistry. Nothing. So you have to find mole fraction. It is the partial pressure over total pressure, and you're good to go. So the partial pressure here is what? 0.8, while the total pressure here is 1.05. Divide. What do you have? 0.76, right? Now, mole fraction does not have unit. It doesn't, because the partial pressure on top, the unit is atm. The total pressure under has the same unit, so the unit on top will have to cancel that one under. So the formula for mole fraction is nil, nothing. It doesn't have any formula. Okay? If you have question, ask. And make sure you are writing. Make sure you're writing all these things down. And make sure you are punching your calculator as well. The third one. Oxygen gas from the decomposition of potassium chlorate was collected by water displacement. The barometric pressure and the temperature during the experiment were 97.4 kilopascal and 20 degrees Celsius. Remember, we have pascal for unit of pressure, and kilopascal. Okay. What was the partial pressure of the oxygen gas collected in kilopascal? What was the partial pressure? We are looking for partial pressure. Let's check what we have in the question. The total pressure is given. Hope you know that. 97.4 kilopascal. How did we know that that thing is total pressure? Read the question again. Oxygen gas from the decomposition of potassium chlorate was collected by water displacement. The barometric pressure and the temperature during the experiment were, you see it now, the pressure during the experiment is 97.4, while the temperature, we don't need temperature now. Temperature is always constant in partial pressure. So we are looking for what? Partial pressure. Remember our formula. You remember, partial pressure is equals to P total is equals to PA plus PB. So we have our P total, which is 97.4, and we are looking for the partial pressure plus what? 2.34. How did we get the 2.34? How? Can somebody tell me? Do you remember the standard pressure? The standard STP, standard pressure. If you remember the value for standard pressure, tell us now. So if you divide your standard pressure by 760, you have 2.33, which we are going to use as the P for CO2. So if you make the partial pressure, the subject, you have that your partial pressure of oxygen gas is 95.0. We have two gases here, CO2 and oxygen. CO2 and oxygen. So if you make that of oxygen the subject, you have 95.0 kilopascal. Are you with me? Alright, these are the things I want you to do. And you're submitting them now. Do the two questions, submit them here and now. Okay? If you have any question, ask. I will answer you. Have a great day.